Hi everyone, welcome to another video brought to you by Math Icon Institute. In this video, we'll be discussing divisibility rules. In mathematics, sometimes we might be faced with the challenge of dividing the number. We want to divide a large number by 2, by 3, or some other divisors. Then you will need the first-hand information to see if you can divide the number perfectly by the divisor without doing the division first. So there are some rules that guide us through that. That is, you can decide beforehand that is this number divisible by 2 or 3 or 4. That's even performing the division. So we use these rules we call divisibility rules. Then there is for 2, 3 up to 10. So that of 2 is a number is divisible by 2 if it ends in an even digit. A number is divisible by 2 if it ends in an even digit. This one wants us to say a number we want to divide by 2. If the number should end in an even digit, then the number is divisible by 2. That's as simple as that. And then note that 0 is an even number. 0 is an even number. So when a number ends in 0, so we can say it ends in an even number. But the first number we have here is 20. Is 20 divisible by 2? Yes. Why? Because it ends in an even digit, which is 0. 0 is an even digit. So it is divisible by 2. So let's confirm. 20 divided by 2. 2 in 2 is 1. 2 in 0 is 0. That's 10. So we are correct. The next number we have is 32. Is it divisible by 2? Let's confirm. Now, the law states that the number should end in what? An even number. And 32 is ending in 2. 2 is an even digit. So we can say it is divisible by 2. Let's confirm that. 32 divided by 2. That's 16. Yes. Yeah, answer you are correct. The third number we have here, 576. 576. Is it divisible by 2? Yes, it is. Why? Because it ends in an even digit. It ends in 6, which is an even digit. So you can try to divide it. 576 divided by 2. What do we have? We see that 2 in 5 gives 2 in that 1. 2 in 17, that gives 8 in that 1. Then 2 in 16, that gives 9. That gives 8. 28. You are also right. And finally, 1058. Is it divisible by 2? Yes or no? Yes. Why do we say that? That's because it's ending in an even digit, which is 8. 8 is an even number. So 1058 is divisible by 2. Let's confirm that. 1058 divided by 2. So 2 in 10, what do we have? We have 5, right? 2 in 5, we have 2, that 1. And then 2 in 18, we have 5. Can you see? That's 29. So it is divisible by 2. The divisibility rule for 3. So a number is divisible by 3 if the sum of the digits is divisible by 3. So the divisibility rule for 3 states that a number is divisible by 3 if the sum of the digits is also divisible by 3. What do you mean by that? Let's see some examples. We have 18, we have 81, we have 112. No, let's say we have 144. And finally, we have 360. So this rule states that the number is divisible by 3 if the sum of the digits is divisible by 3 also. For example, the first number, 18. Let's see if it is divisible by 3. Now the rule states that we have to add each digit. That is, you have to say 1 plus 8. And that is what? That is 9. Is 9 divisible by 3? Yes. So you can conclude that 18 is also divisible by 3. Once you add the digits of the number and then it is divisible by 3, you can conclude that the number itself is divisible by 3. And yes, 18 divided by 3 gives 6. So we are right. Second one is B, 81. Is divisible by 3? Let's add up its digits. So we're adding 8 plus 1. This is a digit, another digit. And that gives what? That gives 9. Is 9 divisible by 3? Yes, it is. So we can conclude that 81 is divisible by 3. And truly, when you divide, 81 divided by 3, it gives 27. So we are right. The next number, 144, is it divisible by 3? So we sum up its digits. So 1 is a digit, 4 is another digit, 4 is another digit. So add 1 plus 4 plus 4. That gives 9. 9. Is 9 divisible by 3? Yes. So we can conclude that 144 is divisible by 3. The last number we have there is 360. Is it divisible by 3 or not? We simply sum up its digits. 3 is a digit, and that one is 6, and that one is 0. So let's add 3 plus 6 plus 0, that gives 9. Is 9 divisible by 3? Yes, it is. So we can conclude that this number is divisible by 3. So for 3, it is simple. Add up the digits that makes up the number. Those digits, add them up. Once you add them up and the result is divisible by 3, then the number is divisible by 3. So we also have the divisibility rule for 4. And that's as you can see on the screen. So to get that, you double the tens digits of the number, add the result to the unit digit. That is, in the number, you take the tens digit, you multiply it by 2. The answer you got from that, add it to the unit digit of the number. Then the result you got from there, if it is divisible by 4, then that number is divisible by 4. If it is not, then it is not. Let's have examples. So I have 160, 240, 256, then 80. Finally, let's have 4,000. The first number we have here is 160. Is it divisible by 4? Let's see. Now, in a number now, the first number to the right is the unit digit. The one after it is the tens digit. Can you see? So the first number to the right is the unit. The one after it is tens digit. So we said that to multiply the tens digits by 2, double it, 6 times 2. And then what do we do? Now add it to the unit digit. 6 times 2 plus 0 in this case. That's 12 plus 0. That's 12. Is it divisible by 4? Yes, it is. You can also confirm that. For 12 also, 2 is a unit digit. And 1 is a tens digit. So what do we do? We say 1 times 2. 1 is a tens digit. So you double it, 1 times 2. Add it to the unit digit, which is 2. 1 times 2, 2 plus 2, 4. Is 4 divisible by 4? Yes. So you can conclude that 160 is divisible by 4. Next number is 240. 240. Is it divisible by 4 or not? Let's see. This is the unit digit, the rightmost number. The one after it is the tens digit. So let's double it. Double the tens digit according to the rule. 4 times 2. Add it to the unit digit plus 0. 4 times 2 is 8. 8 plus 0 is 0. And as we all know, 8 plus 0 is 0. Also, 8 is divisible by 4. So we can conclude that 240 is divisible by 4. The next number is 256. 256. 256. Is it divisible by 4? Let's see. 6 in this case is the unit digit. So it's the rightmost digit. 5 after it is the tens digit. So the rule says that we should multiply the tens digit by 2. We double it. 5 times 2. Add it to the unit digit plus 6. 5 times 2 is 10 plus 6. That is 16. Right? Also, even though we know 16 is divisible by 4, but let's try to confirm again using this rule. 6 is the unit digit, while 1 is the tens digit. According to the rule, what do? We double the tens digit. We say 1 times 2, add it to the unit digit plus 6. 1 times 2 is 2 plus 6. That is 8. Is it divisible by 4? Yes. We can conclude that 2, 5, 6 is also divisible by 4. And the last number we have here is 4,000. This is the unit digit, the rightmost number. This is the tens digit. Double the tens digit, 0 times 2. Add it to the unit digit plus 0. Because 0 times 2 is 0 plus 0. 0 plus 0 is 0. Is 0 divisible by 4? Yes, it is divisible by 4. Because 0 divided by 4 gives 0, which is divisible by 4. So we can conclude that this number is divisible by 4. Then you can apply it to any other number. Then to even numbers with 4, 5, 6, 7 digits, the rule still holds. Move to the rule for 5. This is divisibility rule for 5. A number is divisible by 5 if it ends in 0 or 5. This is quite simple. A number is divisible by 5 if it ends in 0 or 5. That is, once you see a number, we want to divide by 5. We want to know if it's divisible by 5 or not. Does the number end in 0 or 5? If yes, then it's divisible by 5. The answer is no, then it's not divisible. Take note, 0 is an even number. But here, we're not saying if the number ends in an even number. If it ends in 0 specifically, not all even numbers, 0 or 5. You can have 180. You can have 200. 10,000. You can have 5,000. Or let's even say 8,500. 255. 625. 785. So let's see. Let's now have 238. So the first one here, 180. Does 180 ends in 0? Yes, it ends in 0. Then it is divisible by 5. Can confirm that 180 over 5. 5 in 18, that's 3. Remember that 3. 5 in 36. You can see. Just as we said. Second one is 200. Does it end in 0? Yes. It is divisible by 5. Confirm. 200 divided by 5. That's 40. The third one on the list, 10,000. Does it end in 0? Yes. So it is divisible by 5. Then confirm. 10,000 divided by 5. That is 2,000. We are correct. The next one is 8,500. Does it end in 0? Yes. It is divisible by 5. You can confirm that. 8,500 divided by 5. So 8 in 5 is 1 remainder 3. 35 is 7. 5 in 0. I said 8, sorry. 5 in 8 is 1 remainder 3. 5 in 35 is 7. 5 in 0 is 0. 5 in 0 is 0. Is it divisible or not? It is divisible, obviously. We are also correct. Now, for the ones that end in 5, we have 255, 625. 255. Does it end in 0 or 5? It ends in 5, which is divisible by 5. Let's confirm that. 255 divided by 5. 5 in 25 is 5. 5 in 5 is 1. So we are correct. The next one is 625. Does it end in 0 or 5? It ends in 5. So it is divisible by 5. Let's confirm. 625 divided by 5. 5 in 6, that's 1 remainder 1. 5 in 12, that's 2 remainder 2. 5 in 25, that's 5. Is it divisible or not? Yes, it is divisible. The next number we have 785 and 238. 785. Does the number end in 5 or 0? It ends in 5, so it's divisible by 5. Let's confirm. 785 divided by 5. 5 in 7, that's 1 remainder 2. 5 in 28, that's 5 remainder 3. 5 in 35, that's 7. So we are right. It's divisible by 5. Now, I intentionally brought a number here, a number which is not divisible by 5, to test if that will it still holds. So divide this by 5. 5 in 23, that's 4, remainder 3. 5 in 38, that's 5. 5 38, that's 7, remainder 3. You can see it has a remainder. So it's not exactly divisible by 5. Try to check all other numbers. Numbers that do not end in 0 or 5. Numbers that end in 2, 3, 4, 6, 7, 8, 9. Any number at all, divide by 5. Then you see that it's not divisible exactly by 5. Thank you.